Transformations, reflections, rotations, dilations for chapter 4, geometry. Let's start with transformations, okay? Now, when we're transforming things, we're moving things in two-dimensional space, meaning the x and y intercepts, right? The x and y coordinate plane, okay? So, we're dealing with moving things up, down, left, or right, okay? When we want to move something, just move it, right? We're just going to add to it or subtract from it. But subtraction is an addition, right? So if I add a -2, it's like subtracting 2. Does that make sense? So we're always starting with an x and a y, okay? And we're moving to an x plus a and a y plus b. Now that b could be negative, the a could be negative. That makes sense? Okay. Now let's take a look at it in a small factor. Okay? If I want to move something, let's say this something, right? And let's say that this is 1, 2, 3, 4, 5, right? So this is a 5 something, and this is a 3 something, and this is a 1 something, right? And then obviously it's a -1, 2, 3. So -3, -3, -1. Okay? Does that make sense? Now, if I want to move it, right, I'm just going to add to it. Okay? So I can add 3. Let's do something. Let's add 2 to the x's. We'll say x plus 2, and we'll say y plus a -2, or -4. Let's do that, -4. Okay? No, let's not do -4. I want to go up. So let's do let's just +4. Okay? Because then I'll bring it down, and I don't want to come down here. Okay, so x plus 2 is going to be 5, right? So the new one, why the heck? These are all negatives. I'm an idiot. Because that's -3, -5, -1. Sorry about that. But if I want to add a 2 to the x, right? Then I'm going to come over 1, 2. And that's going to be my new x. Right? So that's going to be -1. Okay? If I want to add 4 to the y, that's going to be 3. Okay? So -1, so we're going to move this over to 1 and 3. Okay? So we're just moving it. We're moving it right and up. Does that make sense? Right 1, or right 2, and up 4. Okay, now I'm going to move this point, right 2, and up 4. Okay? Which means that would just become right 2 would be a -3, and up 4 would be a 1, right? And then this one, I'm going to do the same thing. I'm going to go right 2, so 1, 2, and up 4, 1, 2, 3, 4, okay? So this one's going to become +1 and a 1, okay? And then that's the translation here is right 2 and up 4. So we're just moving it right and up. So we're adding to it. We're adding to the x's, we're adding to the y's. Translation, just moving it. Okay? These other translations have a specific movement. Okay? This can go in anywhere I want. Transformation means I'm moving that triangle or pentagon or hexagon or whatever it is, and I'm moving it right or left, and then I'm moving it up or down. Okay? So right or left or up or down. That's transformation. Okay? And that's always adding. Okay? Reflection, whole nother story. Okay? A reflection is that I take this x and this y, right? And I'm going to reflect it. Kiko, we need to take some notes, bro. Come on. I'm going to reflect it across either the x-axis or the y-axis. And it's very important to know which one I'm dealing with. The first one we're going to deal with is the y-axis. Okay? Now, in order to deal with the y-axis, what that means is I'm taking this function, this graph or triangle, I'm going to reflect it and make this one. Okay? Now, if I go, this would be across the x-axis, right? And this one would be across the y-axis, right? So in this case, I want to reflect it across the y-axis. Okay? I want to reflect it across the y-axis. So the only thing that changes, right, is that the x's become negative. That's it. That's it. So this x becomes a negative x. The y's stay the same, right? Because they're at the same height. But this x becomes the negative x. So this x goes to right here. This goes to right there. And this goes to right there. It reflects. Okay? It flips across. Bam. Okay? Now, if I want to go this way, right? If I want to reflect this direction, okay, I still start with an x and a y, right? But I want to go against the x-axis, which means, what do you think is going to change? The y. Very good. The only thing that changes here is that the y becomes negative. Okay? So, reflections are pretty easy. Either the x becomes negative or the y becomes negative. That's it. Okay? So in this case, if this were a 1, 2, 3, 4, 5, and a 1, this would be a 1, 1, 3, 3, and a 1, 5. And then what would happen over here is that this becomes a negative 1, 1. This becomes a negative 3, 3. And this becomes a negative 1, 5, 1. Sorry about that. This becomes a negative 5, 1. Okay? So the x has just changed. Down here, the y's changed. So this 1, 1 becomes 1, negative 1. This 3, 3 becomes 3, negative 3. And this 5, 1 becomes 5, negative 1. That's it. That's all you're doing. Just changing the y's or changing the x's to the opposite. Does that make sense? Kind of? Sort of? Hang in there. Alright, there's a lot going on. Okay, next, rotations. Okay? Rotations are a little bit more complex, but not much. We still start with an x and a y. Okay? But we need to know, are we rotating at 90 degrees? Our rotations that we're going to do are always 90 degrees. Okay? 90 or 180. Okay, so let's start with the 90. We're going to start with the 90 degrees clockwise. And a clockwise is also considered in a downward. Okay? Because clockwise is this way, and so we're going down. Okay? And when we change 90 degrees clockwise, I want you to think of rotation as rotating the x and the y. Okay? You're rotating the x and the y. But what happens is that one of them becomes negative. And this x becomes the new y, right? But it becomes a negative y. Okay? So, again, if we were to look at a okay? In fact, let's change this. Let's have a little more fun with it. So this is a 2 and 1. And this is a 3 and 4. And this is a 5 and 2. Okay? And if I were to rotate that one 90 degrees clockwise or downward, right? Then this 2 and 1, that would become 1 and 2, right? So, but the 2 is going to become negative. So 1 and negative 2. Okay? 1 and negative 2. Okay? And so, and then this one becomes a 2, 5. So 2, negative 5. Right? And then this one becomes a 4, negative 3. So a 4, negative 3. Okay? So 90-degree rotation. Okay? So it's just coming down this way. Now, if I want to go the other direction, okay? The other direction, my X and my Y in a 90-degree counter clockwise, right? Or in this case, up. Okay? So in this case, I'm going to go in the other direction. I'm going up, right? I'm doing the same thing. Remember, rotation. What do I want you to remember with rotation? Just throw your pins. Now I want you to remember, rotate the X and the Y. Okay? And in this case, your Y becomes negative. Okay? In this case, your Y becomes negative. Okay? And so, if I were to go this direction with it, it's still going to be 4 and 3, right? But my negative 4 and 3. Okay? Negative 4 and 3. Alright? Negative 2 and 5. So negative 2 and 5. Okay? And then negative 1 and 2. Okay? That's not what we're doing. Switch them. Okay, and so you should be able to see the 90-degree rotation. Okay? All right. The last one. We were going to do brown. Dilation. All right, so think of what happens when we dilate. All right? Do things get bigger or smaller? So I have half of you say bigger, half of you say smaller. Bigger. Who says bigger? I got 4. Who says smaller? I got 2. Nice.
2.
Yeah, back there. Denise.
She did. Yeah, she did. Did she? Yeah. Oh.
All right. I'm going to say that you 2 are right. And you 4 are right.
Oh.
But you're all half right. See, no one's wrong in this game. It's a game of all half right. Or hopefully Kiko, if he was off his phone, would have said, no, I believe that they're both. Right? And that's why I can play around on my phone, because I know that I know this stuff. So, they're both. Right? So when I multiply something by 2, does it get bigger? Yeah. If I multiply something by 5, does it get bigger?
Yeah.
If I multiply something by a half, does it get bigger? No, it gets smaller, right? So then that's what dilation is, right? We're going to multiply these points to make this either smaller or bigger, okay? But we got to multiply both of them. So that's the key, okay? So what we're going to do here is we're going to take this letter K times X and K times Y. Alright? And that number is going to make this either smaller or bigger. Okay? So I can take I can take something like this 1. Let's go. Yeah, screw it. 1, 2, 2, 4, and 1, 4, right? So we got 1, 2, and we got 2, 4, and we got 1, 4, right? Or we got 4, 1, sorry. And I'm going to make it bigger. I'm going to make it 2 times bigger, right? So to make this 2 times bigger, then everything would be multiplied by 2. Does that make sense? So the 1 becomes a 2, right? The 2 becomes a 4. Okay? The 2 becomes a 4. And the 4 becomes a 8. Up there. And the 4 becomes an 8. And the 1 becomes a 2. Now it shifted, but it dilated. It got bigger, right? Now, could I make it smaller? Sure. What if I multiply it by a half? Right? So if I multiplied it by a half, the 1 would become a 1/2. And the 2 would become a 1. And the 2 would become a 1. And the 4 would become a 2. And the 4 would become a 2. And the 1 would become a 1/2. And that would be smaller. Half the size. Okay? All right. Are we good? All right. Hopefully that got all of that.